what is a unit or an identity matrix? When we were talking about scalar matrix again, since what we are doing is essentially we are going one step below the other. So diagonal matrix, the liberty was that any element can be anything. The first diagonal element can be something, the second diagonal element can be something else, the third diagonal element can be something else again. When we put a restriction that all the elements on the diagonal matrix of a square matrix, on the diagonal of a square matrix need to be same, then we come across something called a scalar matrix. The liberty is that the same value can be different. So we can have 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 700, 700, 700, 700, 456, 456, 456, 456. 1 plus 2i, 1 plus 2i, 1 plus 2i, 1 plus 2i. We can have anything. We can have minus 100, minus 100, minus 100, minus 100 as well. In the next step, that is when we move from scalar matrix to identity matrix. So we have discussed scalar matrix. Now when we move to the identity matrix, we put another restriction. So what is the restriction that we put here? We say that aij is 0 for all I not equal to j. This is the same as the condition that we have considered when we are talking about diagonal matrix and scalar matrix, and aij equals 1. So the final restriction that we put is all the elements on the diagonal matrix need to be 1. That is my definition of unit matrix or an identity matrix. So essentially, when you say diagonal matrix, I can say, okay, the off diagonal elements are all 0, but I don't know what are the elements on the diagonal of the square matrix. When you tell me it's a scalar matrix, I can say, okay, I know that the off diagonal elements are 0 because it follows from the diagonal matrix, and all scalar matrices are essentially diagonal matrices. And I can say that the elements on the diagonal of the matrix are all same. So if you tell me one of the elements, I can say that all the other elements on the diagonal of that square matrix will be the same. But I cannot say which value it is. When you finally tell me that it's a unit matrix or an identity matrix, I can instantly say that, okay, all the elements on the diagonal of the square matrix will be 1. That is 1, 1, 1, and 1. So at the moment that you tell me that I'm talking about an identity matrix, I can construct the entire matrix because the elements on the diagonal matrices are 1, elements on the diagonal of the square matrix are 1, and the off diagonal elements are 0. So I can say the entire I can say the entire matrix when you say that the matrix that I'm talking about is an identity matrix in nature. So that is what I mean by an identity matrix. The final thing is all identity matrices are scalar matrices as well as diagonal matrices. All scalar matrices are also diagonal matrices. So when I'm talking about the 7th point, the 7th is already the 6th and the 5th. The 6th is already the 5th. It goes in this direction. So from a diagonal matrix, you put a limitation and you reach at a scalar matrix, which means that a scalar matrix is also a diagonal matrix. From a scalar matrix, you put another limitation and you reach at the identity matrix, which means an identity matrix is a scalar as well as a diagonal matrix. So the final thing that we'll be talking about for today is the upper triangular matrix and the lower triangular matrix. Do note that upper triangular matrix and lower triangular matrix are sometimes together called a triangular matrix. So essentially a triangular matrix is of 2 types, upper triangular matrix and lower triangular matrix. Now, what do I essentially mean by an upper triangular matrix? Let's look at the matrix that I already have here. So I have marked some things for you. Essentially, if I have the elements on the green portion that I've marked, so let me mark this portion for you. If I have this marked portion, all the elements on the marked portion to be 0, and the other elements on the matrix are non-zero, then I say that the matrix considered is an upper triangular matrix. This is because the upper portion of the matrix forms the non-zero triangle of the segment of the matrix. That is, 92, 92, 97, all these are non-zero elements, but 64, 83, 59, these are 0 in nature. So we don't have this section. Essentially, we have this section, but this is null in magnitude. So this is called an upper triangular matrix. Similarly, again, if we have the elements on the, sorry, let me just remove this. Yeah. if we have the elements on this side to be 0, that is 64, 78, 98, all these elements are 0, and only these elements, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements are non-zero in nature, then we say that the matrix considered is a lower triangular matrix. Now, how can we represent it in notation form? We say that an upper triangular matrix has Aij equal to 0 for all I greater than j. So let's look at it one at a time. Aij is equal to 0 for all I greater than j. Let's look at the element Aii, A11. So 1 is not greater than 1, which means it's not 0. This element is not 0. If I'm talking about the upper triangular matrix, let me remove this portion. Let me mark this portion for you, because that is the definition, or that is how essentially an upper triangular matrix works. So Aii, A11 will not be 0 because 1 is not greater than 1. This element will be the element which corresponds to the first row and the second column. So it's A12. Again, 1 is not greater than 2. So this element will not be 0. Similarly, A22. 2 is not greater than 2. So this element won't be 0. This element, let me mark it with a bigger, much more emphasized number. This element lies at the intersection of the first column and the second row. We consider the row first, so we will say the second row and the first column. So this is A21 because we consider the row number first and then the column number. So 64 is that A21 element. 2 is greater than 1, which means this element will be 0. Similarly, A31 will be greater than will be 0. A41 will be 0. A32 will be 0. A3 this is third row and the second column. Yeah, A32 will be 0. A42 will be 0. A43 will be 0. All the other elements will be non-zero. So that constitutes an upper triangular matrix. Similarly, we can have a lower triangular matrix. Again, we have given the condition here. For a lower triangular matrix, we have Aij equal to 0 for all I less than j. So this will be the reverse. We'll have elements on this side to be 0. You can try it out on your at your home during your leisure time. If you do not understand, do let me know in the comment section below, and I will come back and explain the upper triangular matrix and the lower triangular matrix. And what I can do is we can do certain examples and work out sums with respect to the definitions and the different types of matrices that we have considered. And that constitutes the basic introduction to the concept of matrix algebra.